I have to say, and ADDER.C. So what happens? Now you have automatically. Let me remove rm.adder. Remove. That is the right way. What is the command? This is the command. Command to generate assembly code. What is assembly code? That is the machine code. Machine code, which is being executed at the lowest level. That assembly code is generated from your C coding list. All right. How can you get assembly code? Then you need to do GCC minus uppercase S followed by the source code ADDER. Then automatically you have ADDER extension S. We never say this file here, right? We never say ADDER S here. We specify the source and then option S. Then this file is named automatically. And if you want to look at that assembly code, then you need to do, say, cat and ADDER.S. Then you can see all the assembly code, which is generated from.
Which was the last command? The last command that you were using?
I did a cat.
Oh, okay. For the assembler.
Yeah, cat. You can use cat or more. Cat. If you say cat, then it open up and the content of entire content of that file. There's a command cat. I think from the concatenate. I'm not sure where it is. Maybe catch. If you do more, instead of a cat, M-O-R-E, then it gives you page by page. So one page is from the beginning of that file. Remember that up there, the file name is ADDER.C. And then there is somewhere the global variable main, and main is nothing but type, function. In the main function, something like we have a move. These are some registries, EAX, and some memory space, RSP. So move this value to EAX, another, and this EAX moved to another. So LC1 and LC0 and LC1, maybe two variables. And then divide here, div. So RBP here, which is here, the first one, divided by this is RBP, it's moved there. Anyway, it's a divide, and then if you hit spacebar, then next page. This is this assembly code. We are not learning, we are not coding any assembly code here. But I want you to know a little bit. So if you see here, this is a command. Left column, whatever, there is a command. Followed by like some other code, right? 2 or 1. Here print, here's some value to somewhere. So it assigns internally in the memory I have a value, then that value should move into this memory space. And then if we want to assign this value to another, then it moves to another. And very, very primitive command to be used here in assembly code. If you see here, call, move, some types of move, div, there's a division, and very, very primitive. The operators are used in such an order. That is the assembly code. So your coding list is more in powerful language. We do not say, for example, if you say copy, then we simply say copy or string copy. Very high level. But internally, if you want to copy, then what happens? Then you have to create one memory space here. Then somehow memories should be managed. The real example is this. Let's say swap. If you have this two values, you want to swap it. How can you swap? At least you need to have one additional space extra, right? If you want to swap, say A and B here, then you need to move this A to here temporarily, and then move this guy to here, so this is not anymore A but B, and then move back this guy here so that it's A. Basically, internally, although at the high level, we can say simply swap, but at the low level, a lot of sequence of operators to be specified. That is assembly code. Okay, so I want you to know only that much. Here, LC0 and LC1. Remember that above we see the LC0. That is a long, which means I said float type, right? Therefore, it is called long and aligned maybe 4 byte long. That is this, and LC1 another. That is also long. LFE, the size of that is main and section and so on and so forth. If I change that to, for example, go back to VI. If I change that to int, see what happens. Int and simply I need to change this to D to D, and then I will do the same thing like this, and then I will do the S, then a lot simpler, right? Before, when I do floating points, then I have
LC0.
Right, but now we do not have that. Integer is manipulated in easier way. LC0, LFB. Remember that when we assign here, first when you declare A, then it comes from some of these labels. But here in this case, it's directly from the registries. So that type of things. So assembly is something that machine or processor can understand. All right? So that is assembly. We don't do yet debugger. Okay? Let's change our program a little bit. VI. Here, let's say P is not anymore 4, but let's say 0. Change it to 0. What happens? Remember that? Look at the main function. Integer A equals 3, P equals 0. and then I want to divide those two variables, A and B, but unfortunately, variable B holds 0. It turns out that invalid division, right? Denominator, in division, denominator should not be 0. If it is 0, then what happens?
It's not defined.
Clearly, yeah, you're right. It's not defined. What do you mean by not defined? We cannot define it, right? What is the division, by the way? For example, 10 divided by 2. What does that mean? 10 divided by, number 10 divided by
You split it
2.
into 2. You put it in 2 groups.
What does that mean? Split it into 2 groups.
You put 10 into 2 groups.
So what is the answer?
5. No. Right. Yes, it is 5.
Split it into 2, then it doesn't mean any.
Yes.
Yeah, you're right somehow. Let me explain. Let me rephrase what she wants us to say. 10 divided by 2 means, we can say, how many 2's in 10? How many? 5. 5 2's in 10, right? 10 divided by 5, for example, then how many 5's in 10? 2 5's, right? That is a division. So if you say 10 divided by 0, how many zeros in 10? None or so many?
Infinity.
Infinity or none? Both are right. In mathematics, it is not defined. Right? 10 divided by 0. And if the denominator is other than 0, then our definition is perfectly right. But as far as 0 denominator, then our definition is not working. So we can say simply undefined. This program is doing that. We have 2 variables, A and B. We want to divide it. See what happens. This is a simple program, so we know which one is wrong, right? Which statement is wrong? A divided by B, that is wrong, right? See here?
Yes.
When I move, I'm losing cursor. Oh, here. Okay, here. This, something wrong here. Because denominator should not be 0, but I said 0 here. But as an example, let's see what happens. ZZ and compile. Now we want to compile rather than generating assembly code. How can you do? GCC minus G if we want to do debug. And then you need to generate object file minus O. Object file, let's say that is adder, and our source code is adder.c. That is a command. If you want to do debugging, after you compile, then you have to do that. And enter. And then if you see the list of the files in that directory, then ls minus L means long list. Long list means we have all kinds of file attributes. Not only the file name, we have 4 files, adder, adderc, .c, .s, and a.out. But it has timestamps so that we know when it was generated. ADDER generated recently compared to assembly code or A.out, right? But A.out and ADDER both are executable files. So in Ubuntu, in the file name is colored differently. But not only that, if you see here, the access control code, you see here, these two files, like green, it is all X given. Assembly code and source code, there's no X. X means executable. R means readable. W means writable. So access control is given in Ubuntu, Linux operating systems. But we have a repetition of this. RWX, RWX, and R-X. Sounds like there are 3 sets, right? Three specification, each of which is an access control given to 3 different groups. The first 3 combination RWX given to the owner. Who is the owner? This is the owner. And another JUN, there's a group. If you say JUN is the owner, in this case, because we didn't do anything, right? So owner is the same as a group, which means I'm the owner, also I'm the group, no one else. But in real Linux operating systems, we can say, hey, you're all in the group of IASP 595 summer 2015. There's a group. Then your username remains the same, but at this time you are at a different group. What it means here is that first 3 access code given to the owner, and then next 3 access code given to the group, and then finally given to public, general. Okay? Then you can see here, anyone over here, any file cannot be done by anyone else in public. What is it? Cannot be done what? Cannot be read or cannot be executed, cannot be written. What is it? If you look at this code. You lost interest? No one answers. Well, let's forget it. There's a little deeper. But anyway, that is Linux. So now we need to debug, right? Debug. What was the issue? Let's say if you compile, if you execute ADDER, what happens? Oh, floating points exception core dumped, which means there's an error, right? And then core dumped. Let's see if it is a core dumped. Well, actually, no core code dumped. What is a core? Core. Some segment, code segment, because of it has errors, this compiler cannot do anything. Because of that, then it dump out that code. It is called the core dump. It happens in C program. Well, you don't see any core here. So there are two things. You need to know how to dump core, number one. Number two, anyway, we can see the GDB. Okay? So let's first get into the debugger. So GDB is debugger. Debugger calls object file, ADDER. Where is my object file? Object file is here, -o ADDER. So you need to call this object. -g -o ADDER, then you need to call that ADDER for the debugger, GDB. And enter. Read that. GNU GDB in Ubuntu, copyright license. This is free, no warranty. GDB was configured as x86_64 Linux GNU. That is where we are, right? We have been doing type show configuration and bug reporting instructions. Please see that website if you want to see more about GDB. Find the GDB manual that is there and type AP ROPOS word to search for command release to word and whatever that, right? So here, what we can do, let's say help all, the list of all command. So help all command can be listed here. So step 1 instruction. If you want to trace instruction by instruction of that code, you need to do NI. Also continue program being debugged, but run it in reverse. RNI, SI. SI is a step 1 instruction exactly. And command classes, breakpoints. If you want to breakpoint stop at some points, then you can do also breakpoints. Break and return, catch and delete, disable, enable, ignore, save, skip, S trace, T break, temporary breakpoints, T catch, trace, watch, set a watch point for expression, and then for data you can do display of sum and append, dump, binary code, memory region or reset memory, output, print command is also very useful here if you want to see some variable, content of some variable, and set it's a lot of settings. maintenance. Print set per command. A lot of those. Show per command space. Python command also possible here. And run, start to debug the program. We can run it, we can kill, we can interrupt, jump, thread, backtrace, print backtrace, PT, print backtrace over all stack frames. Those are useful also. Info address, info arguments. It's a lot of information. Info breakpoints, if we have multiple breakpoints. Info frame, info locals, info mem, memory regional attributes, info OS, info source, macro, show, a long list. Show debug, all kinds of debugs. Okay, anyway, so we can do quick. Okay, quick. Let's try runs, and then it's starting program, program received the signals, FPE, arithmetic expression, and in the main program, adder.c, line number 8, and that is a place. It stops there, right? This one gives also disassemble the main memory, main method, main function. Then it gives you in more detail in the main function. Do you remember the main function? First, we declared A and B with number. So A and B, push this here. Initially, don't do anything. This is about main. And integer A equals 3, B equals 0. Then move in hex 3, number 3 to all BP. All BP is already declared here, so 3 variables. This is A, and this is I think it's maybe B, right? Let's see. And then here, floating points. So some memory spaces. This is a memory. This is a memory.